Now in this video we will revisit one of the laws we had already met at some point, and then we are going to from there learn a new law. And once you kind of understand them, they are kind of intuitive, so I hope they don't require a lot of memorization. It's more the process that is good to memorize here. And so the first one is this first bullet point, is that when two exponential expressions are the same, are equal to each other, and their bases are the same, that requires that the exponents are the same as well. So that is then the statement over here, that the exponents are the same, and then the same vice versa. If the so if the two numbers are the same, and then I take a base and I put each of those numbers into the exponents, then the result of that is also the same. So it goes both ways. That's what the if and only if means. And in the very same way, the second law also operates, just now with a logarithm. So if we have two logarithmic expressions being equal to each other with the same base, so they're always required to have the same base, then the argument, the inside of the logarithm, the x and the y, have to be the same. Again, we're here. Or if two numbers are the same, and then I take the exact same logarithm to the same base of each of them, then the answer again is the same, is equal. So it again goes both ways. We are going to apply that now, once in the exponential equation and then once in the logarithmic equation. Now in the exponential equation we are actually going to do that twice with two different logarithms, while in the logarithmic equation we are only doing it once. So in the case of the exponential equation, we could basically, based on the second law, just take, say, well, we have a number on the left, we have a number on the right, so that means if I take the logarithm of each of those numbers, then that still equals, the left side will still equal the right one. So that will look like this. So if I take the logarithm, in this case I'm going to choose base 3, but we are later on choosing another base, x minus 4, but here I'm just choosing it because it's a base that is there already. Logarithm to the base 3 of 15. Now, as we have practiced already and know already, that's another law, that the logarithm to the base 3 of 3 to something in the exponent is simply that exponent. So I get again the same answer, and it is logarithm to the base 3 of 15, and then I add 4 on both sides at the very end. Now, how is that going to look on the right side? So here now I have a logarithm, so I'm gonna take the upper new rule and then take each side and put that in the exponent, and of the base I'm going to again choose the same base, 9. So I'm going to have here a pretty big expression. So 9 to the logarithm to the base 9 of x minus 7. And then on the right side, I also put the right side also into the exponent and get again 9 to the 81's power. Now this is similar like we had on the on the exponential equation. When we solved that, we evoked that law, that logarithm to the base 3 of 3 to a number is that number. Here is the other way around, 9 to the logarithm of the same base, 9, of a number is just simply that number. It's technically not cancelling, but oftentimes people use that term here as well, just to memorize the process. And then at the end we add 7 again on both sides. So that worked really well because we had on each side only only on one side an exponential expression and only on one side a logarithmic expression, and so we could choose just freely the base of whatever we were given already. Now for the logarithmic equations, that's also the extent to which we are doing that in this class. However, on the exponential side, we will learn to also solve exponential equations that have a different base on each side. So there's another exponential expression further down the road on the right side, and they each have a different base. So then the question is, which base should our logarithm have? And the answer is, it doesn't actually matter. So I'm going to show this here on an easier example, that we can just freely choose another example and get a similar answer, kind of the same answer, but we might have to work for a moment to show that that's the case. So I'm going to rewrite that same original equation over here, and I have 3 to the x minus 4 power equals 15. And so now, instead of choosing logarithm to the base 3, I'm going to choose a different base, and since I like ln so much, I'm going to use ln, the natural logarithm, and that is of 3 to the power of x minus 4, and then on the right I get ln of 15. I could have also chosen the logarithm to the base 10, or any other base. So now on the left side, we cannot, since we don't have the same base, we cannot just say, oh, that's my exponent. However, if you remember, a very important logarithm property is that I can take that exponent and put it up front. So I can now write here x minus 4 in the front, and then what I'm left with is ln of 3, and that equals ln of 15. Then I divide both sides by ln of 3, and I'm left with x minus 4 on the left side, and here I have ln of 15 divided by ln of 3. Now please do not be tempted to cancel anything here or apply a logarithm property, because for the logarithm property that you might be thinking of, we have to have one logarithm and then the division inside the logarithm. However, we can apply a different property, which is our change of base property again. And if we there chose our logarithm to the base 3, we could just, right, because that's in the denominator, so then we could just write this very same logarithm, so ln of 15 divided by ln of 3, write that as logarithm to the base 3 of 15, if you apply that change of base formula. I'm first going to write it one more time, however, with the ln's to make another point. So that's ln of 15 divided by ln of 3. I'm adding 4 now on both sides. So I get plus 4. And so this is a way you can easily put it into any calculator that you have, any scientific calculator, where you have most scientific calculators have an ln and a logarithm, so just logarithm base 10 available, but no other base. some of them more fancier, or in decimals, we can now use the different bases, but not yet on the just simple scientific calculators. So therefore, this is a way to write it out that is you can actually type directly into any calculator that you have available. Now, if you just wanted to leave it again as a most compact form for your answer and leave it in exact form, then you can rewrite this as logarithm to the base 3 of 15 using our change of base formula and then adding 4 at the end. So that is another way, and you will meet this way again where you just take any logarithm really on both sides, and often using either ln or logarithm to the base 10. As long as the definition can be applied, you're welcome to use that one. So then you have a choice, but if you have an example where you can only use the second method, then you need to be ready to apply that.